ফর ক্লাস 10 স্টুডেন্ট, আমি আগের দিনকে তোমাদের করিয়েছিলাম কারেন্ট ইলেকট্রিসিটি চ্যাপ্টার থেকে স্টার্ট করেছিলাম, যত অবধি গিয়েছিলাম তারপর থেকে পড়াবো। ওহমস ল থেকে আজকে পড়াবো। ওহমস ল আমরা জানি কোনো পরিবাহীর তাপমাত্রা এবং অন্যান্য ভৌত অবস্থা যদি অপরিবর্তিত থাকে, তাহলে ওই পরিবাহীর মধ্য দিয়ে যে তড়িৎ প্রবাহ মাত্রা তা ওই পরিবাহীর দুই প্রান্তের বিভব প্রভেদের সমানুপাতিক হবে। তো আমি যদি ধরে নিই এটা একটা পরিবাহী এবং এই চিহ্নটা হচ্ছে রোধের চিহ্ন, পরিবাহী মনে করা হচ্ছে এ বি পরিবাহীর এ থেকে বি এর দিকে আই প্রবাহ মাত্রা যাচ্ছে, এ প্রান্তের বিভব ভি এ, বি প্রান্তের বিভব ভিবি। তাহলে তাপমাত্রা এবং অন্যান্য ভৌত অবস্থা যদি অপরিবর্তিত থাকে, ওহমের সূত্র অনুযায়ী ওই পরিবাহীর অর্থাৎ এই এবি পরিবাহীর প্রবাহ মাত্রা তা বিভব প্রভেদের সমানুপাতিক হবে। এবার বিভব প্রভেদ বা পোটেনশিয়াল ডিফারেন্স ভিএ মাইনাস ভিবি, ঠিক আছে। অ্যাকর্ডিং টু ওহমস ল, I is proportional to VA minus VB if temperature and other physical conditions are remain unchanged. তাহলে সেক্ষেত্রে আমি ধরতে পারি যে VA minus VB by I equals to কনস্ট্যান্ট ধরে নিলাম, সেটা কে। তার মানে বলা যেতে পারে VA মাইনাস ভিবি ইকুয়ালস টু আই কে, ঠিক আছে। এবার এই VA মাইনাস ভিবিকে আমি যদি ধরে নিই ভি, তাহলে এটা হয়ে যাচ্ছে ভি ইকুয়ালস টু আই কে। এটাই ওহমের সূত্র, গাণিতিক রূপ, দ্য ম্যাথমেটিক্যাল ফর্ম অফ ওহমস ল। এখন এখানে যে কে ধরা হয়েছে, দ্য কনস্ট্যান্ট টার্ম কে, সেটার বেসিক্যালি দ্য রেজিস্ট্যান্স অফ দ্যাট কন্ডাক্টর। কোনো পরিবাহীর যে ধর্মের জন্য তার মধ্যে দিয়ে তড়িৎ প্রবাহকে সে বাধা দান করে, সেটাকেই বলা হয় তার রেজিস্ট্যান্স বা তার রোধ। তাহলে সেক্ষেত্রে ফর্মটা হয়ে যায় ভি ইকুয়ালস টু আই আর, অর্থাৎ আর ইকুয়ালস টু ভি বাই আই। এখান থেকে আমরা ওই কন্ডাক্টরের রেজিস্ট্যান্স সম্পর্কে জানতে পারি এবং তার ডেফিনেশনটাও পাওয়া যায়। পোটেনশিয়াল ডিফারেন্স টু দ্য কারেন্ট ইজ কল্ড দ্য রেজিস্ট্যান্স। কোনো পরিবাহীর বিভব প্রভেদ এবং প্রবাহ মাত্রার যে অনুপাত বা ভাগফল, সেটাই হলো ওই পরিবাহীর রোধ। এই রোধের একক হচ্ছে ওহম, চিহ্ন হচ্ছে এরকম, ঠিক আছে। তার মানে আমি 1 ওহম ইকুয়ালস টু ধরতে পারি 1 ভোল্ট বাই 1 অ্যাম্পিয়ার। অর্থাৎ কোনো একটা পরিবাহীর দুই প্রান্তে যদি 1 ভোল্ট বিভব প্রভেদ থাকে, পোটেনশিয়াল ডিফারেন্স থাকে, এবং তার মধ্যে দিয়ে যদি 1 অ্যাম্পিয়ার কারেন্ট ফ্লো করে, তাহলে সেই পরিবাহীর যে রেজিস্ট্যান্স হয় সেটা হচ্ছে 1 ওহম। এবার এটাকে যদি আমি গ্রাফিক্যালি রিপ্রেজেন্ট করতে চাই, তাহলে আমি মনে করলাম গ্রাফিক্যালি রিপ্রেজেন্ট করতে এক্স অ্যাক্সিস বরাবর আমি পোটেনশিয়াল ডিফারেন্স দিলাম এবং ওয়াই অ্যাক্সিস বরাবর আমি দিলাম কারেন্ট। তাহলে দেখতে পাওয়া যাবে যে এটা মূল বিন্দুগামী একটা সরলরেখা হচ্ছে, অ্যাজ আর ইকুয়ালস টু ভি বাই আই, এবং এটা একটা মূল বিন্দুগামী সরলরেখা হবে। তোমাদের হয়তো অনেক সময় প্রশ্ন করবে যে ওহমের সূত্র অনুযায়ী যদি ভি আই লেখচিত্র অঙ্কন করা যায় তাহলে সেই লেখচিত্রের প্রকৃতি কিরূপ হবে। তো এটার প্রকৃতি হবে মূল বিন্দুগামী সরল রেখা। It will passing through origin and it will be a straight line. যে সমস্ত পরিবাহী এই ভি বাই আই ইকুয়ালস টু আর এই ফর্মটাকে মেনে চলে এবং যাদের ক্ষেত্রে এই লেখচিত্রটা স্যাটিসফাই করে, দে আর অল ওহমিক কন্ডাক্টর বা ওহমীয় পরিবাহী। বা ওহমিক কন্ডাক্টর। ঠিক আছে, এইবার এর ওপরে কয়েকটা ম্যাথমেটিক্যাল প্রবলেম আলোচনা করে আমি তার পরের অংশে যাব। তার আগে বোর্ডটা আমায় মুছে ফেলতে হবে। বোর্ডটা মুছে ফেলে আমি এর ওপরে দুটো মতো অঙ্ক আলোচনা করে আমি চলে যাব পরবর্তী অংশে। কি বলছে? The potential difference across a conductor is 5 volt and the current is 0.2 ampere. Find out the resistance of that conductor. So the potential difference is 5 volt across the conductor and the current is flowing, which is 0.2 ampere through the conductor. You have to find out the resistance of that conductor. Therefore we know that V equals to IR or R equals to V by I. Let us consider that the resistance of that conductor is R. Therefore what we have, R equals to V equals to 5 volt and I equals to 0.2 ampere. So what we have, that 5 into 10 divided by 2 ohm, that means it is 25 ohm. So the resistance of that conductor is 25 ohm. Okay, now come to the next mathematical problem. The next mathematical problem is দুটো পরিবাহীর প্রথমটির রোধ দ্বিতীয়টির 4 গুণ। উভয় পরিবাহীর দুই প্রান্তে বিভব প্রভেদ একই হলে পরিবাহী দুটির মধ্যে দিয়ে তড়িৎ প্রবাহ মাত্রার অনুপাত নির্ণয় করো। The resistance of first conductor is 4 times of the resistance of the second one. তাহলে the resistance of a conductor is 4 times than that of other one, than that of other conductor. Okay. Potential difference is same for both conductors. Find ratio of current through them. So we consider one conductor AB, another conductor CD. The current flowing through the first conductor is I1, the second is I2. The potential at A point is VA and the potential at B point is VB. Here also VC and VD. According to question, VA minus VB is the potential difference of the first conductor and VC minus VD is the potential difference at the second conductor. But according to question, VA minus VB equals to VC minus VD equals to V. So the potential difference is same for both conductors. But the resistance of the first conductor AB is R. If it is not R, if it is R, then it is 4R because 4 times than that of other conductor. Therefore, we can write V equals to I1 4R. That means 4R I1. It is number 1 equation, and again V equals to I2 R. That means R I2. Second equation. So what we have, I1 equals to V by 4R, and here I2 equals to V by R. Now I1 by I2, we have V by 4R divided by V by R. So this is 1 by 4. That means I1 is to I2 equals to 1 is to 4. That is the answer. Okay. If it is okay, then we are going to the next part of the chapter, that is EMF and internal resistance of any cell, any source of EMF. So first of all, we have to remove the board. We have to remove the content of that board, not removing the board. Now we have to study EMF. That we know that electromotive force, and it is the electromotive force is associated with the battery or the source of the electricity. Mainly it is associated with cell. And the internal resistance. Internal resistance, which is small r. Internal resistance is actually associated with battery again. So we are talking about the source of electricity, which is cell, its EMF and its internal resistance, how they are related. Okay. So first of all, we have to just draw one circuit. Here we have the battery and a small resistance we have drawn. It is a key, it is the external resistance R, it is the internal resistance. This total thing under the box as if this box is the battery and the internal resistance R is within this box. That means the resistance of that battery is R. The big line indicates positive and the small line indicates negative. So the current is moving from left to right. Okay. The current is moving from left to right. Now, if the EMF of that cell is E and if the current through that circuit is I, then what we can write? We can write E equals to this R and the small r putting together in series, this one. That means I can write I equals to E by capital R plus small r. Or through this equation I can write E equals to I capital R plus R I small r. Now the potential difference across this external resistance is V. So what is that? IR. So we can write E equals to V plus IR. Therefore, V equals to E minus IR. So whatever the potential across this resistance, whatever be the potential difference we have across the load, the resistance of that circuit, we consider the total load is denoted by the capital R. So the potential difference across this load R is V is actually not equal to the EMF of that battery. It is less than the EMF of that battery, which is actually subtracted by its internal loss of potential. That means these IR, this potential or this voltage we can't use. So it is said to be as lost volt. This IR is said to be as lost volt. Nosto volt. Because you cannot use it. It has no use in giving you the power. It has no use for operating the devices of the circuit. So this is called the lost volt, and this is basically has no use. Okay. Now come to the next mathematical problem associated with this lost volt and internal resistance. Here we have one Daniell cell of EMF 1.08 volt EMF. It is connected to a circuit and it gives 0.5 ampere current, but in external circuit we have 0.7 volt. Though the battery is given, though the Daniell cell is delivering 1.08 volt EMF, but due to the internal resistance of that cell, at the external circuit we are getting 0.7 volt and the current is given 0.5 ampere. So we have to find out the internal resistance. So what are given? The EMF of the Daniell cell is given, the current of that circuit is given, and at the external circuit across any load we are getting the voltage, that is 0.7 volt, which is less than 1.08 volt. We are not getting 1.08 volt out of 1.08 volt because we know that due to the internal resistance, the lost volt is there. So you have to find out the internal resistance. Now we know that E equals to 1.08 volt and whatever V we have, that is 0.7 volt. I equals to 0.5 ampere. We have to find out resistance R. Okay. Now we know that E equals to V plus IR. Where from we are getting this equation? From the last deduction we are getting this deduction. Therefore IR equals to E minus V. That means E equals to 0.08, 1.08 minus V equals to 0.7. So we have 0.38. that is IR. That means I equals to 0.5 ampere into R equals to 0.38. So R equals to 0.38 divided by 0.5. That is equals to 0.76 ohm. So the internal resistance of that cell is 0.76 ohm. Basically the internal resistance is always very small. If internal resistance is high, then the cell cannot deliver electricity, cannot deliver the electromotive force due to the high internal resistance. Always remember that internal resistance is always less. Okay. Now come to some other features of resistance. What is that? The resistance is depending upon the length of that conductor, and it is also depending upon the cross-sectional area of that conductor. So if resistance R is there, it is directly proportional with the length of that conductor. As the length increases, the resistance will increase, and R is inversely proportionate with the cross-sectional area, which is 1 by A. Now putting together, R is proportional to L by A, and R equals to rho L by A. What is rho? Rho is resistivity. Rho is resistivity. Okay. So rho is AR by L. AR rho RA by L. AR by L. Okay. So if we consider the length is 1, the cross-sectional area is 1, then rho will be equals to R. So we can say that for unit length of any conductor of unit cross-sectional area, the resistance between two opposite surfaces or faces is the resistivity of that conductor. And this resistivity is measured in CGS system ohm centimeter, and in SI it is ohm meter. Okay. If anyone say that the resistivity of copper is 1.68 into 10 to the power minus 6 ohm centimeter, that means definitely some temperature will be mentioned. That means at 20 degree centigrade temperature, 1 centimeter length, 1 centimeter square cross-sectional area of a copper block or copper block, the resistance between two opposite faces is 1.68 into 10 to the power minus 6 ohm. That is the meaning of the resistivity. Now, the just opposite of resistivity is conductivity. The opposite of resistivity is conductivity. Conductivity, that means resistivity is the degrees of offensive force with the direction of the current. The virtue due to which the conductor is offering some offensive force against the conventional way of current is called the resistivity. Just opposite of that, that is conductivity. How is the conductor is allowing the electricity to move through it? How easily? That is measured by the conductivity. And therefore conductivity is actually sigma, which is 1 by rho. It is reciprocal of rho, and by the same way its unit is also different. That is, the unit of sigma or conductivity is the opposite of ohm. Ohm, its opposite is mho, mho. So if I am writing ohm meter, that means it is the conductivity meter to the power minus 1. That means mho meter to the power minus 1. That is the unit of conductivity. Now come to the conductor and the insulator. Actually, those substances allowing current very easily through it is called the conductor, and those substances are offering opposite forces which are not allowing the electricity to pass through it is called the non-conductor, or it may be termed as insulator. In between these two, there is semiconductor and superconductor. So first of all, for the conductor, the resistivity is almost 10 to the power minus 8 ohm meter to 10 to the power minus 6 ohm meter in case of the conductor. Okay. In case of insulator, its value is 10 to the power 10 ohm meter to 10 to the power 17 ohm meter. In case of, this is for conductor, this is insulator. This is for insulator. Okay. So we are going to semiconductor. Semiconductor are those substances which have the conductivity greater than insulator, less than conductor. So their resistivity, and the example of some semiconductors are silicon, germanium, etc. So their resistivity is around 10 to the power minus 5 ohm meter to 10 to the power minus 2 ohm meter, which we can find very easily. That is within the range. They are not as good as conductor, they are not as insulator. And if we draw some curve of semiconductor with increment of the temperature and their resistivity, how their resistivity depends upon temperature. If we draw some curves, then we have x-axis. Along x-axis we consider temperature, and along y-axis we have the resistivity. So we have this kind of curve. Okay, that means according to the increment of temperature, the resistivity decreases for semiconductor. Okay. Now, if the temperature is decreased for any other metal which is ohmic conductor, their resistivity decreases. Their resistivity decreases with the decrease of temperature. So there are some metals and compounds where the temperature, at a certain temperature, their resistivity becomes 0, and it is called the critical temperature. And then if the resistivity is 0, that means there is no resistance. There is no resistance means it becomes superconductor. Okay. And the graph of that kind of conductor, if we plot it along x-axis temperature and along y-axis it is the rho, that means resistivity. For the superconductor, the curve is like that. It is for superconductor. And it is semiconductor. Okay. Now, this is all about today. We will study the next part in our next discussion. Okay? Up to then, take care of yourself.